We are going to learn how to solve trigonometric equations today. So first of all, let's go over the steps that you're going to need to follow, okay, to solve an equation. First, we're going to simplify the equation. And you do that with as much algebra skills as you can. So if both sides need to be divided by 2 or something like that, but you don't want to change the angle. Okay, the second step is you draw mini unit circles. So this is the thing that we just studied, where you have a little circle, a unit circle with the angles on it and the points, and then you write the equation. Okay, so then next you make the equation, okay, and possibly a chart of values if you have to evaluate. Okay, so we've already learned how to do step 3, make the equation, but today we have to draw our own circles. Okay, for example, let's look at this first one here. Whenever it says solve in general means you make an equation. The equation states all of the answers forever, all of the answers in terms of an equation. Okay, so there's no baby algebra here to do. It says cosine of theta is 1/2. So starting today, you have to draw your own mini unit circle. So let's think about the unit circle. Where is the cosine positive 1/2? Now this does not say inverse, so you're not restricted to a certain domain. You can look everywhere. Cosine is 1/2 up here at pi over 3. Okay, and where else is it positive? Right down here at 5 pi over 3. Okay, so we don't go down, we go 0 and then the first positive one, so we're doing the regular kind of stuff. We're not restricted to domains 1 and 2. This is not inverse. This is look everywhere. Okay, let's take a look at these equations. I can say this answer as x equals pi over 3 plus or minus, I'm going to have to say that angle by himself, 2 pi n. And let's say this one here by himself, so x equals, go around positively, 5 pi over 3 plus or minus 2 pi n. Okay, and so those are the two equations. Now there is a way, remember, to combine these answers into one equation. Since it's make an equation, since it says solve in general, you can combine these because look, if you go up or down, it's the same distance. So you could say x equals, let's start by going up or down. How much is that up or down? It's going to be the same value, pi over 3. And then you'd say, after you get to that value, go around a full circle, 2 pi n. So these two equations can be combined into one equation. Okay? And that's a good idea when it says solve in general. Okay, that's how you solve a trig equation. So pi over 3, or if you add another 2 pi, that would be 7 pi to 3. If you put 7 pi over 3 in there, is cosine of 7 pi over 3 also 1/2? Yes. What if I add another 6 pi? What if I do 13 pi over 3? Would cosine of 13 pi over 3 also be 1/2? Yes, forever and ever. Okay. Now, when it says solve the equation in the interval from 0 to 2 pi, that means you're only allowed to go around the circle one time. And I want to solve the equation for actual values. So that means you have to make a list with a chart. Make a list. You have to use a chart of all answers in one circle. Okay, let's show you how this is going to work. Okay, first of all, let's get that mini unit circle and see if we can figure out where the angles are. When it says tangent is radical 3. Let's put radical 3 over 1. So this is the sine, and this is the cosine. Okay, we learned how to do this already, but let's just refresh for everybody. Can you think of a place where the cosine is 1 and the sine is radical 3? I don't recognize that at all. Maybe what we need to do is that over 2 trig. Maybe the denominators got canceled out. Yes, these are familiar. Okay, what angle am I thinking of where tangent is positive? So one of the places is pi over 3. Come on, people, where's the other one? Where's the other one? I hope you're down here in quadrant 3, and the answer is 4 pi over 3. All right, so I have the angle, I have the thetas, where tangent is radical 3. So do I need to write this as two separate equations, or can I write one equation? Remember, writing one equation means less work. I think we can combine these because this is halfway across the circle. So what's the name of the angle? Theta. Okay, so theta equals, where's the answers? Pi over 3 plus or minus, what's the distance that you go over and over to get to more answers? Pi n. Now, if it said in general, okay, let's just write an answer here. If it said solve in general, you would stop. But it doesn't say in general, it says in the interval. Okay, so what we do at this point is we make a chart. Some people just make the chart right there using that equation, and it saves some space. Okay, so what we're going to do is we're going to say let n equal 0. So if n is 0, if you don't add anything, the first answer is pi over 3. Okay, now we're going to let n equal 1. So what we're doing is we're going to go all the way around the circle, finding all the answers. What's a good idea sometimes to make your life easy is make common denominators here. So instead of pi n, let's write it as 3 over 3n. So what we're going to do is take 1 pi over 3, add 3 more, and that makes 4 pi out of 3. And we can keep going. If n is 2, what's 4 out of 3? And you need to add 3 more. That's going to be 7 pi over 3. Okay, and the question is, when do you stop? Well, we need to say all the answers between 0 and 2 pi. So how much out of 3 is 2 pi? 2 pi is 6 out of 3. So 6 is too much. So this answer right here is no good. That's over 2 pi. How much out of 3 is 2 pi? 6 out of 3. In fact, this parenthesis right here means that you do not use that value. Do you know why we can't use 2 pi? The answer is because you're using 0. You can't use it 2 times. You've already used that place. So what they want you to do is say all the answers starting at 0, go one full circle, and stop. Just make me one complete list around the circle. Don't keep going round and round. Okay, so let's make a nice solution set. The angles are pi over 3 and 4 pi over 3. So what I want you to get very good at is drawing the unit circle, making the equation in general, making a chart, letting n start with 0, 1, 2, and there it goes. Some people want to know, why don't we minus pi? Well, if you start at pi over 3 and you minus, now you're going negatively. And they only want the answers from 0 to 2 pi. They want one set of positive answers. There's one set. You're going to see how tonight's homework is going to be nice and easy, that your answers are going to match your unit circle. But that's not always the case. So let's get real good at following the directions the proper way so that tomorrow, when things change up a little bit, you'll have this process down. Okay, let's do some more. All right, this says solve the equations from 0 to 2 pi. Okay, so what that means is you have to make a list of answers. A list of answers. Okay, they don't want an equation in general. They want you to start at 0, go all the way around back to 2 pi. They want you to include 0, but not 2 pi, because you've already used that answer. Okay, let's take a look at this. Is there any baby algebra we can do to solve this equation? Well, yeah, let's subtract -3 first. 2 sine of theta equals negative radical 3. Let's divide by 2. So what you're doing is you're dividing the left-hand side by 2. Not the angle. You don't mess the angle up. You just divide the side. So sine of angle theta is negative radical 3 over 2. All right, so I'm trying to think. Let's draw a little circle here. I'm trying to think of the angles where sine is negative. Sine is negative in quadrants 3 and 4. Where is the sign that? One of them is 4 pi out of 3. Good. And the other one is 5 pi out of 3. Very good. Okay. Can we combine these into one equation, or are we going to have to make 2 equations? 2 separate equations. Okay, so let's do 4 pi to 3 all by himself. The name of the angle is theta. Okay, so theta is where? 4 pi over 3 plus or minus 2 pi n. And then the other angle, let's make a separate equation for him. Theta equals 5 pi over 3 plus or minus 2 pi n. Okay, now if it said solve in general, we would be done. But it says in the interval between 0 and 2 pi, so they want a list of answers. So we're going to go ahead and make some charts here. The first value that you start off with is n equals 0. And when n is 0, the first angle is 4 pi out of 3. Now remember, they only want the answers from 0 to 2 pi. They don't want you to go past a full circle. When I let n equal 1 and I add 2 pi, am I going to be less than a full circle? In this case, I'm not even going to bother adding 2 pi because 4 pi out of 3 plus 2 pi is going to be more than 2 pi, so that's going to be too much. But if you wanted to try to do stuff like that, you should probably make a common denominator, 6 over 3. And 6 plus 4 would be 10 out of 3. Well, out of 3, how much is too much? 6 out of 3 is too much. Okay, same thing over here. When n is 0, your answer is 5 pi over 3. Should I even bother adding 2 pi? No, because you're going to be more than 2 pi. So the answers are 4 pi over 3 and 5 pi over 3. We put them in a solution set, and we put them in order from smallest to biggest, and that's just a nice way of making a set of answers. So again, this first assignment, your answers are going to look just like your unit circle for today only. It's a good way to check, but that's not always the case. All right, let's do another solving one. The first thing I need to do is divide both sides by 2. Okay, you don't change the of, it's just the coefficient in front. So now we've got sine squared of theta equals 1/2. Now we still have to solve some more because you have to get that squared out of there. So I will square root the left-hand side, and I'll square root the right-hand side. And now it's just sine of theta. Okay, over here, do you know that you can take the square root of the numerator and the square root of the denominator? So radical 1 is 1. Radical 1 is 1. And radical 2 is radical 2. Why, we can't leave it like that. Let's go ahead and rationalize. Radical 2 over 2. Wait a minute. Did you forget something? I just took the square root. Remember, when you square root, don't forget plus and minus. Okay? Put that in red. Put a star right here. This happens a lot, and I don't want you missing any points on the test coming up when we have the square root ones. All right, let's draw a little mini unit circle. This one's fun. Where is the sign, positive or negative, radical 2 over 2? Okay, lots of places. The pi over 4s, right? 1 out of 4, 3 out of 4. How about down here? How about 5 out of 4? Is that a place? Yes. Okay, plus or minus, you got lots of answers. 7 over 4. Now we're going to make an equation. The name of the angle is theta. Name of the angle is theta. So theta equals. Are we going to need 4 separate equations, or do you know how to combine this into one equation? I think one equation is going to work, right? Pi over 4. And how much do you add to get to the next one? 1 out of 4, 2 out of 4. 2 out of 4 is how much? Pi over 2n. Excellent. One equation. All we need to do is make one chart. One chart. Theta equals. I'm going to make my life a little easier here by writing the equation with a common denominator. So let's write 1/2 as 2 over 4. Okay, that's going to make the chart a little easier. So here we go. If n is 0, you get pi over 4. When n is 1, what's 1 out of 4 plus 2 more? Remember, every time we have to add 2 out of 4. That's going to make 3 out of 4. All right, what if n is 2? What's 3 plus 2 more? 5 pi out of 4. How much is too much out of 4? 8. 8 out of 4 is too much. So let's keep going. What if n was 3? What's 5 plus 2 more? 7 pi out of 4. Is that okay? Is 7 divided by 4 still less than 2? Now 8 out of 4 would be too much, so should I add some more? No, it's time to stop. So the solution set is pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Solving equations is kind of tricky sometimes. The students say if they follow this process every time that they're going to do okay. All right, the last equation here. Let's get at it. First, we'll divide by 3. So tangent squared of theta is 1/3. Okay, what are we going to do next? Square root. Square root. So tangent of theta is, okay, don't forget that nice tricky thing, plus or minus. What's a radical 1? 1. Radical 3 is radical 3. Now, I'm not going to rationalize. I kind of like it like this. I'll do that over 2 trick. This is the sine. This is the cosine. Okay, so I'm trying to think of a unit circle. Where is the cosine that and the sine that? Okay, so I hope you're saying 1 pi out of 6. Where else is it? Positive or negative? How about 5 pi over 6? Anywhere else? How about 7 pi over 6? And how about 11 pi over 6? All 4 places because of plus or minus. If you forget that, you're probably going to lose half the answers, and half of it will be missing. Okay, how many equations can we make out of this? If we combine these two, because they're halfway across the circle, that would be nice. I can't combine all of them. That's a big space. That's a little space. So let's do these two. Theta equals, the angle's theta, right? Yes. Pi over 6 plus or minus, what's the space halfway across? Pi n. Let's write this equation. So theta equals, you find the first positive one, 5 pi over 6 plus or minus pi n. Okay, and I have to make some charts. What I'm going to do is write pi, just to make the fraction part easier, 6 over 6. Okay, let's get started. When n is 0, we get pi out of 6. When n is 1, what's 1 plus 6 more? 7 pi over 6. How much out of 6 is too much? 12. Can I add 6 more? Nope, that would be too much. All right, let's go over here. N is 0. 5 pi over 6. Okay, let's add 6 more to that. 5 plus 6 is 11 pi out of 6. So people just go down the chart adding 6. 11 plus 6 more, that would be 17. 17 over 6 is too much. Remember, we have to stop at 2 pi. Okay, so let's make a solution set in order. What comes first, 1, 5, 7, or 11? 1 out of 6. And then we'll put the 5 pi over 6. Then the 7 pi over 6. And finally 11 pi over 6. Put them in the solution set. Box up your answer. For the first assignment, you can check by looking here at your unit circle. But that's not going to happen starting the next day. But I hope this makes sense, and I can't wait to see you.